So the agenda for today is that first we'll talk a bit about authors and instructors. Then we will talk about what does this course look like. And then we will start with what exactly is DevOps. Then we'll do a case study on DevOps, a very brief case study just to keep all of you engaged and keep you in context. And then we will do a brief overview of the entire landscape. All right, so regarding the instructors or the course authors, we are three people in this course who are building this course, which is going to be very different from what is existing right now in the industry. And this is very important to keep in mind that all the three people are very hands-on and have a good experience of developing and deploying large-scale software for quite many years. I started my career long back in 2002 and graduated from IIT Roorkee, and then I worked with D. Shaw, Amazon, InMobi. I even founded another company before CloudX Lab. It's called Td Global, where we manage the documents, and there was a proper enterprise-grade software that we built. And based on my experience with Amazon and my own startup and D. Shaw and InMobi, I believe that DevOps is something that is integral to software engineering. No matter from which background you are, whether you are a front-end engineer, data scientist, machine learning engineer, or you are a system admin, or you are let's say DBA, the DevOps will help you in solving your problems. The DevOps will complement your existing skills, and the DevOps, the various components, knowledge will help you in almost every phase of the software engineering. Even if you are from, say, a product manager background, whereby you need to understand how to create these practices, this course should help you. So I can assure you that. And then there is Ashok Singh. Ashok Singh is again has 18 plus years of experience in various DevOps, data engineer, and software engineer roles. And I'm really glad to have him on the board of this course. Then we have Abhinav Singh. Abhinav is also a co-founder of CloudX Lab. The reason why we have CloudX Lab Seamless running is Abhinav, because he takes care of entire automation of deployment, and that's a classic example of DevOps. Then Abhinav also scaled one of the education services called Byju's. He was working with them, and he has a wonderful experience. So I can assure you that with this course, you are in safe hands, and I'll make sure that you learn the latest practices, you learn the right way, you learn your learning is very, very fruitful in the end. All right, so I can assure you that with all three of us, where we take it very personally, all the things that we are teaching very, very personally, and the subject itself is also very, very, you can say, a hobby as well as a profession to all three of us. So I can assure you that this is the best best instructor authors you could get. Now let's get started with DevOps. I'm going to go ahead with the DevOps now. Okay, so DevOps is essentially the cultural philosophies or practices and tools to help you deliver applications and services at high velocity to your huge number of users. When it comes to millions of users, you need to have DevOps in place. I'm going to talk more about it. Imagine that you are building this e-commerce website like Amazon. It is going to have lots of features, lots of features and lots of users. How are you going to structure your software engineering practice? Anybody? Please feel free to put down your thoughts in the chat. How will we build a website like Amazon.com where you have lots of users and lots of features? Yeah? While on one hand, there is the complexity of so many features, and on another hand, we have the users, huge number of users. And just a trivia, that this is the page at Amazon. This detail page is at Amazon is what I owned. So I can relate to the entire practice very well. The reason why Amazon did so well while other competitors could not stand is because of their wonderful service-oriented architectures and their DevOps processes. And DevOps processes comes from these places like Google and Amazon and other places. Now, great. I got very good answers from the people, right? So one of the old man way of thinking to solve this problem, whereby we have to build a website like Amazon.com, where we are serving huge number of users with so many complex features and delivering the bug fixes very quickly. Yes. How will we build such websites? So the common way to solve such problem is this is a layman's approach. Don't laugh at it. Okay, this is just to give you an idea of how the classic approach looks like. The approach is the classic approach that I keep hearing from people who are not really into the software engineering. It's very simple. Understand the requirement, write the perfect code once because we know all the requirements, and then we deploy it on very powerful server, and then happily fire the software development team because we no longer will need any fixes, right? So this is the approach from the perspective of the people who haven't really developed for large number of users at a very fast pace. And keep in mind that a company like Amazon is not a company is not an e-commerce company. Amazon is a software development company. In the beginning, people thought that it's an e-commerce company, or you can say commerce company, and the competitors are targets. No, the competition for Amazon is not targets. The competition for Amazon are the companies like Google, because it's a software company. And remember this: if you're building a website, it's not just a website. It's going to be a software company, right? There's the reason when Amazon was building these practices, tools, and that became AWS because they focused on solving users' problem. So again, firing the software development team is not a good idea. Software development is a continuous lifelong process. We must build software in incremental phases. Collaboration between many software engineers is involved in every aspect, because the detail page that I own, this page that I'm talking about, this page that I'm talking about, it has close to 100 features. 100 features. There is a title, there is a byline, and there is a price, and there are variants, there is add to cart. So all of these are features, and the engineers are responsible for these features. So there's a lot of collaboration needed between the engineers. Engineers cannot work in silos. It's so much integrated that you cannot imagine. You cannot imagine how much collaboration is needed between software engineers in a company. This is one of the reasons why any interview you take of Amazon or Google, if you see very closely, their focus is on how well you are able to communicate the problem as well as communicate the solution. So collaboration is the key. Not only collaboration in by the way of voice or by the way of text, but collaboration between the pieces of code. A single page is modified by hundreds of engineers over a year. How are those changes? How are those changes working together? Have you ever asked a book author? Have you met a book author? Ask a book author that can you write a book involving 5 people simultaneously, right? And soon enough you will realize that it'll become the book author will instantaneously say no, it's not possible to get 5 authors write a book unless you can split it into chapters, right? So imagine the complexity of a code which is being edited by multiple users. Now, testing needs to be done the first thing. Now, you might laugh at this sentence that testing needs to be the first sentence. Yes. Testing needs to be done before writing code. How? So you write the test cases, and those test cases serve as specifications. So as you run the test cases for the first time, all of the test cases will fail because you haven't written the code yet. And as you write the code, the test cases will succeed, and that would basically help you stay focused on solving problem because you have the test cases ready. Second, that helps you clearly think about what is it that you're building. So testing needs to be part of the planning. Testing plan needs to be before the code writing. And deployment needs to be more thorough, right? Because when you deploy a highly performant services, like for example Amazon, you deploy to hundreds of machines. All right, so yes, that's called the test-driven development, and I'm going to go more detail into each aspect of it. So stay with me. I can assure you that this session is going to be worth your time. All right, so in case of DevOps, when we talk about DevOps, you start with planning, then you build, then you test, you run the test cases. Here I'll talk about more about various kinds of test cases, then you release, and then you monitor. So this is the DevOps in brief. I'm going to talk about what are the various components here, and you will notice that in the part of the monitoring, right here, just after monitoring you see planning again, because it's a continuous development. It's a continuous development. At Amazon, our code changes were shipped all throughout the year, except for the Christmas. That too in the US, we would stop making new changes. For the remaining 364 days in all territories, we would keep on shipping the changes. On Christmas, even in the non-US territories, we would still ship the changes. So development as well as the deployment, both are continuous process. Both are continuous process. One of the questions that lots of people ask is that how do you test before you code, right? So the general practice is we call it, the general practice that we call is TDD, Test-Driven Development, whereby before writing the pieces of functions, pieces of code, what you do is you just write the skeleton, and then you write another piece of code that verifies whether those functions or those classes or those objects are giving the results. Now in the beginning, all of those functions are empty and therefore they won't give the right output, but they will all fail. All of those test cases will fail. Therefore, you write the test cases before writing the actual code. Now, as you code, these test cases will become successful one at a time. And then you'll get this feeling of accomplishment that you are really on the track, and you will get a clear picture into what you are trying to build. Okay, so there are two parts to testing. Okay, here you see that test comes after builds. Yes, I do agree. But when we talk about coding, coding involves two things. One is called unit testing. Remember, the part unit testing is always part of the coding. Unit testing is part of the coding, though it's called testing, but it's essentially part of the coding. Okay, and the engineers, those who are writing the code, they are supposed to write the unit test cases for their own code. All right, so you can say that unit testing is part of the building or creating the code. All right, so the unit testing part of the testing phase is actually part of the coding. Perfect. So there are many more advantages of the DevOps. First one is the rapid delivery. Okay. Rapid delivery as in you can continuously keep on deploying your software. The delivery of your software wouldn't be one-time event. It will be an ongoing process. The benefits of the DevOps is that when you have it ongoing process, the changes will ship to the customer faster. If those changes are something that users are not liking, you can get the feedback and move ahead. So rapid delivery is the key aspect, key benefit of DevOps. Second is reliability. Now, if there is a slight change in a piece of code, if you keep waiting for if you are delaying the change in the production, the chances are that other pieces will keep on falling apart, and therefore it will hurt the reliability. So if you have faster development cycle as well as faster deployment cycle, then you can be assured of the reliability. Third is the scale. The scale as in if you have infrastructure or automation to deploy your service very quickly, you will be able to deploy to more servers, and hence you'll be able to scale better and operate at the scale easily. Scale as in if you have to cater to millions of users, you will be able to do it very easily because there's a core principle of DevOps that the faster you deploy, and to deploy faster you will have to build automations, and if you have built the automation, you will be able to ship to thousands of machines very quickly, and hence you will be able to scale for hundreds of servers and millions of users. The fourth is the speed. Speed as in innovate for the customer faster. Okay, so you might see that the first and the fourth are similar, but from the business aspect they are different. Rapid delivery is more focused towards deploying the fixes, while the speed is more about being able to change something really faster. For example, let's say a team comes up with a better idea or better changes to keep in mind the coronavirus threat, right? So those companies which have a faster change process, they'll be able to make changes to their website really fast. Those who are not, they'll keep on waiting for various approvals and various deployment, manual deployments or various other delays, and hence they won't be able to deploy. Therefore, the speed is the key aspect. Okay, since it's a continuous process, the speed is the biggest advantage that you will get out of DevOps. Fifth is the better collaboration. You'll be able to build effective teams under our DevOps cultural model. Now, the important part is that in case of DevOps, you will notice as we go ahead, whether you are a front-end engineer, back-end engineer, data scientist, machine learning engineer, or anybody in the whole pipeline, you will be more connected. You will have better collaboration, because collaboration is a key aspect in case of DevOps. Or you can say that DevOps, one of the pillars of DevOps is the collaboration. The more communication, the better communication. All right. Sixth is security. More quickly, while doing all of this, while providing all of the aspects of software deployment, you will get better security. Why? Because the speed and the speed of deployment, as well as the continuity of the deployment, will expose the security loopholes very quickly early in the cycle, and therefore you will be able to eliminate as well as change the design to keep the security in mind. Okay, so what do we mean by DevOps? DevOps has two parts. Dev as in the development phase. Dev as in development phase. Okay, and ops as in operation, right? In the development phase we have, or you can say developer phase or development phase, you have planning, coding, building, testing, and in the ops you have release, deploy, operating and monitoring. Okay, so therefore we call it DevOps. Now let's talk about the first point in the DevOps. First one is the planning. The planning phase involves a goal planning, but keep in mind that the goals need to be shorter. They should not have a larger cycle of development. They should not be like a year. It should be like 15 days. So if we're planning to develop something, we should break it down into shorter goals. If you don't have shorter goals, the chances are that you won't be able to ship them, and it's going to take longer, and by the time you finish them, the market will be over. Your product will not be needed anymore. Now, there's a key part of the planning. Now, planning can be done using any of the Scrum tools, agile planning tools. The various tools that we know of and we use it often is one, the Microsoft Office like Excel and the Docs. You can use Google Sheet and Google Docs, whatever suits your company. The second is the project planning tools. If you have like multiple people in the teams, like 10-15 people, and the work is bigger, then you can use something like Microsoft Planning Project. The third one is the task management tools like Asana, I don't know how do you pronounce it, Jira and Mantis. We use Asana mostly for our planning of the software development. The second phase is coding. Whereby you would need like text editors like Sublime, text editors like Notepad, whereby you write your code and it works, and you write your code, save it, and then run it. So that's the text editors. Mostly people use the IDEs for the statically typed languages such as Java. So people use the IDEs such as Eclipse, Xcode, or Visual Studios. And personally, I prefer to use Sublime or VI for most of my work. So get used to using the text editors. Not only the coding part, but for editing the configuration settings and so on, you would need a text editor. And if you're dealing with DevOps, my strong suggestion will be to use a text editor which has the Unix-like UI, such as VI. Okay. Now, the second part of the coding, the tools that are used for coding, is Scm tools. Scm tools. Scm is essentially source code management. Earlier in 2002, we used to use CVS. How many of you have heard CVS? I don't think so. Many of you must have heard CVS. Afterwards, people started using SVN. And SVN is what we were using, and at Amazon we started using Perforce, and then moved to Git. Now the whole company, the whole Amazon, Google, and everybody is on Git. Git is open source, is completely free for everybody to use, and it's one of the best. It's not one of the best, it is the best source code management tools. So I don't need to really mention any other tool. So Git is something that you should get used to because that's being used everywhere. Okay, it is for the people who are coming from the older backgrounds like SVN and Perforce. It might look a little different, but soon enough you will realize the reason for its design. And the next thing is the server. Where would you keep the code repository remotely? It's called the code repository, where you keep the code on the remote machine. And generally people go for GitLab, GitHub, or you can simply host your own. That's not a big deal. Today, if you're using, say, GitHub, tomorrow you can use something else. It's completely easy, and that's the beauty about Git. Even if, let's say, GitHub was purchased by Microsoft and your code was there, you could simply move to elsewhere. Okay, Git does not lock you there. You can just completely move to another server without losing too much of information, because all the changes are in the Git repository. All right, even if you don't have your own Git server, you can just put it very quickly over SSH. All right, the third part of the code that you get missed out all the time is the test-driven development. And there has been a big fight between the engineers and the testers. The truth is that the test cases need to be written by those who are writing the code. Okay, test cases are also code. Okay, test cases is also code, and it's essentially one piece of code checking the other piece of code is working or not. You might see it like it's a dual development. First I need to write the actual code and then I need to write the test case. No, it actually helps. The rare possibility of test case as well as actual code both being wrong is very rare. Very rare. Therefore, it's actually I wrote my first unit test case in 2003, and there I was using JUnit, and it was weird and it was very unsettling for me to explain all the people that, hey, you need to write the code twice, and I need to explain over and over the test-driven development to all the people. And once the teams started on writing the test cases first and then started coding, they actually got better joy from coding as they were as compared to what they were getting earlier. So there are many unit test case library. In case of Java, you have JUnit. In case of .NET, you have NUnit. In case of I think PyUnit is there for I think it's called something else. For Python is there. So almost every programming language has this package called unit testing. So those who are interested in taking a look at the unit testing in Scala, we have it in our course. the other codes. So our question is that, is unit testing same as exception handling? No. Exception handling is when your code is doing something, what if some error occurs? How to handle it gracefully? That's called exception handling. While the unit testing is writing another piece of code which will check your piece of code, check your main code. Okay, so and when you run this test cases, it will basically run your actual code and test whether your actual code is performing great or not. All right, so that's called test-driven development, or you can say TDD, or you can just say unit test cases. All right, now I'm going to take a little digression, and those who are on their mobile, please come over to a desktop. That'll be better, because I'm going to do a bit hands-on, but that's okay. Even if you are not nearby your computer, it's completely okay, because it's not necessary to do the hands-on now. You can do the hands-on at later point of time also, while watching this video. Just for now, let's just pay attention to what I'm going to do on the screen, and later on you can just watch the video and just follow the steps again. My request is that get hands-on with Linux, and because that's your gateway for automation. Okay, second, get a hands-on with the Git, and then maybe a scripting language will be amazing. Okay, either you could install a Linux machine at your own, or you can just take up a server, or if you're using a Linux based laptop, it's good enough, right? But in our case, I'm going to show you how it works with CloudX Lab, because we have everything set up on CloudX Lab. Now you can just sign up for CloudX Lab. You can just go to say enroll for the lab somewhere. It would be there. Okay, and there's a free trial. Let me just open in a incognito window, and there will be a free trial in which you can sign up. In case you do not want to purchase or anything, you can just do sign up, and you can just sign up with the Google using Google. We don't need any information other than your email ID here. The reason why we have kept the Google is because it's easier, and probably everybody has Google email ID. The one more bit of information is that when you are signing up, it might ask you for a $1 KYC charges. KYC is know your user. So we are since we are providing an infrastructure, we need to know the user, and by having a $1 payment, which will get refunded to you immediately after the transaction, it's just for KYC, that this account will remain active for you for 15 days. You can share the lab, you can share the referral URL with your friends and you can get the 15 days extra. So you can essentially do entire practice for free on CloudX Lab. 15 days is good enough time for you to do hands-on with lots of services and a lot of things. And in addition to the free 15 days lab, we have the various free tutorials like Linux in our lab bundled. So those things will be quite useful to you, as well as you get the entire infrastructure for big data and machine learning. So 15 days is a good time for evaluating the CloudX Lab. Okay, so you can sign up here, and now I had already bought, or you can say that since for me the account has been created already. You can just click on say my lab, and here you can go to say I'll just see. Okay, first of all, I'd like to show you the courses. If you go to my courses, you will find this particular course down there under the name Linux Basics for Big Data. Okay, this course is will be available to you, and you can just click on start, and on the left hand side you will see the questions, on the right hand side you will see the console. Okay, all right, like this. So on the left hand side there is a the theory. On the right hand side, you will see the node Jupyter console. All you need to do is copy paste this login password and log in. All right. The login password you can just copy paste. You don't need to type it. And here you see the console. So this is called the Linux terminal, or you can call it console. Here you type a command. Here ls is a command. ls means list of the files. The second command that is useful is pwd, present working directory. When you log in, you are in a directory, and that's called your home directory. And for me, this is /home/sandeepgiri9034. Similarly, for you also, it's going to be that. Now here, I have lots of files. For you, it will be empty, so it won't show you much. Okay. Now, on the left-hand side, you will see these exercises and theory. Please go through this. This will definitely help you. And also, in case here, if you get into this, let's say, create a directory. Okay, so you could say create a directory. It is asking you to create a directory called XYZ. mkdir is a command to create a directory. Now, how do we pass the arguments to the command? By typing after the space. So I'm saying make directory XYZ. Okay, it says XYZ already exists. Okay, so I can delete that using rm command. Okay, now we can say mkdir xyz. Okay, now if I click on submit answer, it'll check and will give me go ahead. In case I had just deleted it and did not create it, so it will give me an error. Okay, directory not found, please try again. Right, so this is a tutorial, very interactive tutorial. You should finish all the exercises. I can assure you it won't take more than a minute of your time to finish one exercise. That means it'll take like 2 hours for you to just finish the entire course. Okay, this is a free tutorial. I can assure you that after finishing this, you will have a good confidence on dealing with Linux. Why I'm emphasizing on I'm emphasizing on learning Linux is because every automation is done very quickly using scripts in Linux, and not only the Unix scripts but also Python scripts and other programs you can quickly automate from here. Okay, so and for that matter, when you are deploying anything, mostly people are using Linux servers, and that's a very known fact to everyone that everything, anybody who is planning to scale to large number of users generally does it on Linux, not on Windows. And trust me, the Linux part would help you understanding the computer better. All right, so that was one part. Right, ouch, I ended up closing it. Okay, never mind. So all right, so I'm going to go to CloudX Lab again. This time I'll go to my lab, and there I can open the Jupyter and do the, if you are not interested in learning, interested in the course, you can just go to my lab, whereby you will get the details about various services. And here we are talking about, say, Jupyter. Okay, so Jupyter is a web interface to most of the services in Linux. Okay, so by default it gives you a listing of files and folders, and here you can just click on new terminal and it'll open the same terminal that was opened earlier. Earlier it was in split screen. If you want it in the full screen, you can go to the my lab and you can reach here. So I went to my lab, from here. Okay, then clicked on Jupyter, it opened here. This is showing my all files and folders, and here it showed the terminal when I said new terminal. Okay, and all my services that are running right now I can see here. So I can actually kill one of the terminals, the one that was opened earlier in the split screen here. So no worries, don't worry about that part, just go to the new terminal. Again, it's a little tricky here. New terminal. Okay. Now here, let's the next task I want to do is once I have opened the terminal, let's try to create a folder called DevOps, mkdir DevOps. Okay, so I'm going to create a folder called mkdir DevOps. All right. Now here, after doing that, I'm going to change directory to DevOps. Okay. Now this is empty right now. Okay, so this is present working directory is now this, because I did cd, I went inside that directory, and now I'm in this directory. Great. Okay, now wonderful. So this is the place where you get your folder, and moving ahead. So okay, now the Git part. Let's just check if we have really created the directory or not. Let's sort these files or folders which are opened in another tab here. Okay, my data is like too much in this. Someday I'm going to just delete everything. Okay, I've been using it for like 5 years. Okay, so here this DevOps folder is been created, right? DevOps folder has been created. Perfect. And let's just take a look. Yeah. Now let's do a bit of hands-on with Git. Git Git. Okay, Git was designed by the same person who designed the Linux, and all these commands that I talked about you can do on Mac. Yes, you can install Git also on Mac. You don't need to use the CloudX Lab if you have those a Linux-based or Unix-based environment. But I would suggest that instead of haggling around with all these installers, I would suggest that you use this. So it takes at CloudX Lab you can just get it done. But those who want to remain in the control, who want to learn how to install this, you can just install the Git and the other commands on your Mac laptop, MacBook Air or MacBook, and so on. Right now, coming back to Git, Git is essentially a distributed version control for tracking the changes in source code during software development. So when you are developing a source code, the first problem that you will see is that, hey, I want to try out a couple of permutations. For that, I might need to keep the backup of my old code so that I can revert back. Now, for that, either you could keep on creating folders and copies of the folders and so on, and keep on checking the difference. That approach does not work well. Therefore, somebody created a tool like source code management tool like CVS a long back, but that did not suffice. So there have been lots of improvements, and we have evolved the software into Git kind of a version control system. Now it I mean, every change that you are making to your code, you can keep on committing to the Git, and it's essentially like taking the backup of the code. The only difference is that it keeps the track of each change, as well as it does not keep the entire code. It will keep only the changes. Therefore, the storage is extremely optimized. Even if you are making million changes, still the total size of the Git repository is going to be very small. All right. Great, wonderful. So other than that, other than managing your own changes, the other thing that comes into play is how would you manage the multiple developers in the team? If, let's say, multiple developers are working on a feature, they might work on multiple files and their work might overlap. And therefore, there is a need of a tool that could merge the changes by developers. And this is where these source code management tools really help. They can tell you that these are the differences between these two files, and this is done by that, and this is done by that person, and you can merge them. And this is the very good and beautiful part about Git, that it is so easy to manage the changes done by multiple users. So even if you are not a technology person, but let's say you are a lawyer or you are a writer, learning Git is a very good idea. Knowing what is a commit, knowing what is a push, knowing what is checkout, all of those terms you need to be clear about. All right. Now moving ahead, so now let's take a look at the Git. What I'm going to do is I'm going to create a simple text file, and then I'm going to add this code in that and then save it, right? So it's pretty simple. All I need to do is just copy this file name, okay? Copy this file name and this content, and go to the Windows version, the Jupyter Files tab. Okay, so I'm saying new and text file, right? And in the text file, I'm just going to write single line of code, and I'll go back to my presentation. It's basically hello world. I can just type it right there, and now I'm saving it. And I'll just change the name of the file to this. Okay, so it just says print hello world. It does nothing much. Okay, now this is the very simple code in Python, and we have saved it as hello world.py. It's just file name, and we have saved it in DevOps. All we did was new and text file, and that's why we have this code now. Now in the Unix, in the same folder, when we went to the DevOps folder here in our home directory, there must be a file called hello world. You can see that. To see the file in Unix, you can use a command called cat hello world. So it shows that yes, there is something in this, right? And when I say Python hello world, it would get executed. You see that? It got executed, it printed it, right? Now, that means our code is done. Now we want to keep a backup of it so that we make changes to it, So let's try it out, and let's try out the Git for this, right? So I'm going to go to full screen again. Instead of copy pasting, I'll just type it. All right. Okay, so we save the file. Now the next thing we are going to do is we're going to create a Git repository. Any folder we can create a Git repository, but you should always initialize the repository at the top level of your project. So we have created a DevOps folder, right? We are inside the DevOps folder. Inside the DevOps folder, we are saying git init and dot. So we are saying that create a Git repository in this folder. Okay, so now this folder is being tracked in the Git. Okay, therefore it has created a folder called .git, right? If you say ls-a means show all files, even the hidden ones. So it shows that there is a folder called Git. Okay, so inside that you will find all the system, the system folders or files that Git needs, right? These are the various things that Git would need. Right now, it might have empty content. So whenever you commit to the Git, it'll keep the data inside this as well as configuration inside .git folder. All right, but you don't have to fiddle around with this .git folder. All right, now here we said init. Init essentially created a Git repository. This repository is right now local, your own local repository. Okay, repository essentially means the .git folder, as simple as that. Now, repository essentially means the local kind of a folder in which it's going to keep your code. Okay, there's a multiple connotation of repository, but everything is there in the .git folder. Okay, you can have multiple folders in your file system which are not parent of each other. They could have their own repository. Every folder can have their own repository separately, and that could work pretty well. Now, but you cannot have like two repository in the same folder. Okay, so I'll talk about that probably later when you study a bit more. Now the next thing we're going to do is add the newly created file. The newly created file is hello-world.py. So we are going to say git add hello-world.py, right? So we have added it. Right now, Git did not know about the file. So we said git add. Git add means take this file and know that it's going to be tracked. Next thing is that we need to commit this to the repository. Right now it's not committed. So git commit hello world. And here I'm going to write the comment saying this is the first commit. This is my message, so that when I'm going through the backup of my code or the logs of my code, I can see that this is what I had done. So when I say git log, I'll be able to see what all changes have gone, right? Every change is given a name called a commit ID, and so we have just now committed the code. Okay, we just now committed the code. First we created the file, initiated the repository. Okay, this is only done once, and then we added our newly created file and then committed it, and then we checked the status, checked the history of the repository. Now you can see one more thing, that if let's say we by mistake make some changes to this file, right? If by mistake we make changes to this file, so we can simply see what changes we have made. Okay, I think it's not saved. Let me just save. Okay, let's just save it. Git status. Okay, it shows that here it shows that this file has been modified. Okay, we can say Git Diff to see the difference. It just shows that there is a single change, right? This was older, this is newer change, whereby we put a semicolon, right? Now we don't want this change, so we can just simply say checkout. Okay, checkout, and the file name. It'll basically revert whatever it was. Okay, now there is no commit. So whatever change we did has been rolled back. If we refresh it, that change will be gone, right? So this is a very quick use case of Git. There are many more use cases that you will see very soon about the Git. Now, a very important thing is that somebody asked, like, now what's the use of GitHub? GitHub is a remote place where you can keep your Git repository centrally. Okay, I'm going to show this quickly, and then we will move on with our remaining discussion. Okay, now moving ahead, let's say I'm opening github.com. Okay, and I want to go to, say, CloudXLab. Yeah. Okay, so this is my home directory, or let me just do it in my personal one rather than the team one. So this is my Git repository. You'll find quite a few interesting projects there. Here, if you create a new repository, these are my repositories. Okay, so let's say I want to host the changes that we just did into a public repository. Okay, I'm naming it DevOps test. Okay, for testing DevOps hands-on, right? That's so here also I'm creating a repository, right? And it says that if you have an existing repository, you can push it to this. So these are the commands to run. Okay, so I go to my console and connect it, like this repository, the repository in my CloudXLab. I'm just saying that, hey, the remote of that repository is going to be this one that we have just created on GitHub. Okay, now all we need to do is push. Okay, so whatever changes we had done, remember we had created one file, that's being pushed into the remote repository, right? Now if I refresh this page, you will see hello world.py, right? Along with the changes that we have made, and you can see this is the first commit. That was the message that we had written, right? If you make some changes to it, okay, if you make some changes to it, let's say we're printing one more thing called 3 plus 4, right? Not a big deal. Let's just see if it works. Okay, we're committing a change here. So this is on the server. Right now, these changes happened only on GitHub. To bring it to my CloudX Lab folder here, all I need to do is git pull. So that push means taking this repository to a remote repository. Pull means bringing remote repository to the local one. Now let's take a look at this file. Using cat command, you can see that it has come here, right? And I can say Python run hello world and see it has worked, right? So this way you can work with remote repositories. See the way I added, if you notice this command, I added one of the origins as the GitHub. You see, this is the place where my git command, git push, will going to push the local code. Similar to that, we can have multiple origins, maybe one GitLab, other GitHub, and so on. So you can work with multiple destinations or multiple remote servers from the same project folder. It is asking to config when I'm trying to commit. That's right. So you need to just set up the GitHub in order to make it work with your account. So the way I set it up is using the repository, packages, projects, followers, and there is somewhere I had like added profile, not this, settings. There I had put these SSH keys. You can read a little bit about how to generate SSH keys, and once you have done that, it becomes seamless, just like for me. So you can just click on new SSH key and add your SSH key, so that you don't need to log in again in GitHub or any other place. Okay, so generate the SSH key from your machine, whether it's on CloudX Lab or elsewhere, and using these practices. Okay, all right, so that way you will be able to figure out how to make it without locking. So we talked about plan, code, and third part of the process is the build. Build process involves compiling code, copying assets, generating config, and documentation. Those who have used say C code or C++ code, they would know there used to be something called make, right? Similarly, there are many new tools for building your project, because building a project or packaging your project requires a lot of things, like creating a folder in the destination, replacing the config file settings, substituting variables in various files, as well as copying the code, compiling the code, and generating the documentation, and then bundling them together. All of that is part of the build. So building is a very essential part of the work. When you are using IDEs, integrated development toolkits, these IDEs generate the build file or the build script for you. Okay, but the practice these days is that when you are working on a larger project, you should cleanly write your build script. Most of the build scripts are around the convention over configuration, meaning instead of defining that this is my source folder, this is my test folder, this is my destination folder, most of the build these days, most of these compiling systems expect you to do a certain folder structure, and so on. So build process is a very, very important process. The other part of the build process is that when you're building it, it should also run the test cases. I talked about unit test cases earlier. I'm talking about those test cases. So build process should also quickly do a sanity test automatically when you run the build process. So build process should include running of the test cases. Also, there are multiple aspects that I have skipped here. One of the aspect that I did not touch, okay, that I think I'll touch very soon. Okay, so a very common thing that happens in the industry, specifically if you are very software development focused company. So what happens is that when you are writing code, you are supposed to write the test cases as well, and those test cases should be run by the build process as well. I'll talk about the continuous integration after this, but before that I want to talk about the build process. In the build process, there is one more part to the testing called code coverage. A number of times people quantify their testing by saying that we have written 1,000 test cases. But that's not right. The way you quantify how well you have written the test cases is that how much code have your test case covered. Was every condition covered? Are your test cases supplying all kinds of inputs so that all the branches of the code are covered? So to do that, there is a tool called code coverage, cobertura, and there are a few more. What they do is they instrument the code such that when you run the test cases, it tells you how many branches of the code were reached and how many branches of the code were skipped. And that way it keeps an accounting how good are your test cases. Ideally, your test cases should cover all the branches of the code, meaning all if-else conditions, all conditions inside for loop and while loops, and all the functions. But if those conditions are not reached, the code coverage will tell you. The cobertura or similar tools will tell you that this percentage of the code is covered by test cases and this percentage is not. So the code coverage reporting is also integrated into the build process. Now, the build process should work well on the developer machine as well as on a remote machine. Both are very important. You'll find the people who are working with Xcode, or let's say who are working with Visual Studio or Eclipse, their process works on their desktop but not on a remote machine, unattended machine. So very critical part of the DevOps is that build process should work on both the developer machine as well as on the unattended machine, which is not being triggered by manual intervention. There are many tools to make the build process very seamless. Starting with say make. There used to be a command called make in C++, but soon enough for Java programmers Ant came, Apache Ant. Afterwards Maven came. Maven has been the very successful project. So most of the work that was being done by Ant is now done using Maven. Maven has two parts to it. One is called Maven command, other is called Maven repository or artifact repository. I'll talk about that part very soon. So the Maven is essentially a tool which takes the code in certain structure and compiles it and generates the output. Generates the output binary, or it can also run your code, it can run the test cases and so on. It can also upload the things to a repository. The outcome of build is called an artifact. Artifact is like zip file or tzz file, or you can say in case of in Python, it could be OGG file. In case of a web application, it could be .jar file, or in case of Java, it could be .jar file. In case of the web application using Java, it's called war file, WAR, and so on. So you could bundle the project using these tools. For a reference, I had written this writing Spark applications a long back earlier as part of our Spark course, but it's public and free, so you can try it out, try this link out, and it basically covers the process of writing test cases as well as fixing the code. All right, so there are various tools that we will be covering as part of the build process. We'll be talking about mostly Maven and the Gradle. We won't be touching on Ant or SBT because they have been SBT is a brother of Maven, and Gradle is a newer system. So we'll briefly touch upon the Gradle and Maven during the course. Okay, so this will help you understanding. This will help you in understanding the project in a professional environment. Generally, when you're coming from, let's say you studied how to build a web application using a website, and you know how to make it work on your desktop, but if it can't work on an unattended machine, or if there is a new developer in the team, if it can't work on their machine, then probably you need to revisit your build process. Now, moving ahead here, the fourth part: plan, code, build, and now the test. Now, the testing phase is a very important phase. This is not the phase where we run only the unit test cases that we talked about. Unit test cases are anyway being run by the engineers, right? As soon as they build, or when they commit, or they can manually trigger the unit test cases. That's not the main problem. In testing phase, apart from running the unit test cases, what we do is we do integration testing. What does it mean by integration? Let's say I made some changes and another developer in my team made the changes in the repository. I implemented feature A and feature B was implemented by somebody else, but the code was overlapping. We made changes to the same file or same feature in some way, so we broke each other's functionalities. Even though my unit test cases and the other person's unit test cases both will work very well, but the moment the code is combined together, it may not work. The test cases may not work. So the code will be combined, merged, or you can say that it will be pulled out to a fresh new machine after merging. It will be pulled out to a fresh new machine, and then the test cases will be run. Not only that, at that point of time, once it has been deployed to this testing machine, the engineers will manually test various features. They will verify whether the features are great or not. And also there will be stress testing and other mechanisms of automated testing, such as Selenium. Selenium, basically you can emulate the manual testing behavior. You can just record each part, program it so that it behaves like a normal user. Then there could be other test cases, such as sending out emails and so on. Those, if the other tools are not available for the same, you might write your own scripts. Next thing that kind of do the testing is the stress testing. If your deployment is very critical for the users and you want to know how well you are doing with respect to handling number of users, probably you need to do load testing, or we also call it stress testing. There are various tools called like JMeter. I've used JMeter. I've used there was this Silk Testing Pro for testing my application. So we do the stress testing, manual testing, unit testing, and like automation, like Selenium, and sometimes we write our own script to test our code. And And we also run at this point of time the various code coverage tool. And at this point of time, if all the test cases are successful, we move to the next phase called release. Release is essentially shipping the artifact. Artifacts are the result of building. When you have built and it has been tested successfully, those artifacts, we are going to ship it to repository, artifact repository. Artifact repositories, most popular ones are by Maven. Maven repository you can host internally also, so that your artifact remain internal to your organization, and you will keep on pushing those releases to the internal Maven repository. Okay, and this whole process of releasing, maintaining the test can be automated using the Jenkins. Using Jenkins, you can execute all kinds of scripts in a certain fashion. You can check out the code, you can pull out a particular, you can download a particular repository from somewhere, and so on. So Jenkins allows all of that. Okay, so using Jenkins and using Maven, you can do the release. Once that is done, you can deploy it to the various servers. Now, here is a very interesting part. During the testing also, we need to deploy it, and therefore these tools are very much valid when we talk about testing. During testing also, because we have to create a test environment where your program will be, all the dependencies will be installed, and then your program will be checked out and run. So all of that will be automated using these tools like Docker, Kubernetes, and Puppet, and so on. So you will see that during the session. All right, so once the release has been finalized, we can use different tools such as Puppet. Puppet is nothing but a program that can let you run a command, run a Unix command on hundreds of servers automatically. Similar work is done by Chef. Chef also lets you install the programs on all the machines, same does Puppet. Puppet and Chef are kind of used alternatively. Then Ansible is also for managing the configuration of multiple machines. Then there is a salt stack. And these days, what has happened is people like to create something called Docker images. So Docker is essentially like, you know, a machine which can be quickly sent over the wire and can be run or installed on multiple machines simultaneously. So using Docker and Kubernetes kind of infrastructure, you can quickly deploy your website to hundreds of machines unattended. And using Kubernetes, you can do the load balancing based on how many users are there on your website. So you can infinitely and instantaneously scale your infra, and you don't need to log into every machine and manually install it. No, using Docker, you're completely isolated from the local environment. Using Docker, your whatever dependencies you need, they will be installed inside the Docker, and the other packages from outside will not touch you. So Docker provides you that isolation, and these isolated environments can be deployed to many machines using Kubernetes and so on. Similarly, once you have prepared your release in the form of Docker image, we call them, you can deploy it on AWS, you can deploy it on GCP, you can deploy it anywhere by the way of Kubernetes. And that's a wonderful time we are living in. You are not locked into any of the cloud providers. Let's say you are running a website which was dependent on let's say AWS, and tomorrow you realize that the Google prices are better than the AWS. So if you are following the practices like Docker and Kubernetes, and your commands are not really dependent on individual of these service providers, instead your commands are generic, related to more Linux, more Docker and Kubernetes, you will be able to deploy your website to another server as well. And there's a beauty of these new services that are provided, and that's the reason probably Docker and Kubernetes are the main reason why we created this course, because there's a learning curve involved in Docker and Kubernetes. Alright, so you can say that most of the practices involve Docker and Kubernetes also. It's not really replacing Puppet and Chef, it's just that most of the installation is inside Docker and Kubernetes. Puppet or Chef are being used as remote command mechanism or remote installation mechanism. So using these tools, you can pick and choose and create your continuous integration or deployment pipeline. Of course, the Kubernetes and Docker are different tools. Docker images are something that can be deployed inside Kubernetes network. Okay, we'll go into more details. In case you are hurrying up and you are interested in looking at this example, I have created this example a while back. You can try to run it, and I must share with you this. Okay, my repositories. Okay, so this one. Okay, this is a interesting example. You must give it a shot. Okay, in case you are like me, whereby you want to quickly look at the code and how it works, take a look at this project which I created, a sample project, and this is what we will be covering in more details. And similar projects we will be covering in more details as part of this course. All right, this particular project involves the build, the test, it also involves the release mechanism. It also involves deploying using Docker and Kubernetes. So do take a look at this, because we are going to cover this in more details. Okay. Now there is one more thing. After we have deployed it using these tools, the next part is operating. Once the software is in production, users can use it and the product managers can customize it. During the operating phase, we can also measure the effectiveness of various features using the A/B testing. Alright, so further we have to monitor our servers, and that can be done using tools like NegIOS and Apache logging system. Along with that, we'll be learning a system like Grafana, so that we can remotely see the matrices, visualize the matrices of the various servers. It is really easy to debug one single machine, but it's extremely hard to debug a server which is being website which is running on multiple servers. Therefore, these tools are designed in a way that you can remotely monitor as well as review the logs. In case there is an error at any point of time which is being thrown during the monitoring phase and it has gone till the production, we can roll back to a different release just before that. So this happens very often in case of Amazon. What we used to do is we used to observe for common error that is being logged by the system. In case that error message is too frequent, we generally flag it, send a critical message to the team that was managing that particular release, and the engineers would revert back the code to the previous release, and the Amazon website continues, because Amazon website doesn't have the space for any discontinuity in the delivery. Therefore, the logging system, the metric system needs to be in place so that you can measure and find what's happening on your server. In case the service is up or down, you should know that very clearly. Alright, so once you're monitoring using this data, using the data that's being generated as part of the logs, you can plan and again start iterating. you can start improving and iterating. So in summary, this is how it looks like. During planning, you use the tools like Asana, My Project, Excel sheet, Google Docs, and so on. And we use tools like Jira and for tracking the bugs which are being occurring there. So this is the holistic view of the entire DevOps. There would be more tools. There will be more tools that will be including in this. The practices, the best practices of DevOps is something that we are going to discuss now. The first part is the continuous integration. In the continuous integration, we have already talked about that when we have build and unit test stages of the software release process, every code commit triggers an automatic workflow that builds the code and tests the code, and that is called continuous integration. This is done using a combination of tools such as Git, Maven, as well as the Jenkins. All right. This is how it looks like. Developer checks in the code using git push. This is the part where the developer is doing git push. This code repository is basically triggering the CI server, which is building, testing, and giving the results. And the results are reported back to the team. So it helps you find the bugs and addressing bugs quicker, especially if the bugs are related to the integration with the entire team. Because what happens is, let's say multiple engineers are working on the same piece of code. If one person introduced one column in the database and the other person did not care about it, and their code was assuming that there was not going to be a particular column in the database, and therefore even though the individual work is perfect, but when they merge their changes merge, the errors will occur, and therefore continuous integration is very, very important. Continuous delivery automates the entire software release process. It basically extends the continuous integration. Though I am repeating a lot of things, these are the practices that DevOps is essentially practices, tools, and philosophies combined together. We talked about philosophy, we talked about the tools, and we are talking about the practices. CI server is essentially there is a question, though it's a little late to answer that. CI server is essentially continuous integration server. Generally, it is Jenkins, and there are some more practices that we'll talk about how to set it up. Then there is a continuous delivery. Continuous delivery automates the entire software release process. Continuous delivery is essentially extending the continuous integration. So every code commit triggers an automatic workflow that builds the code, tests the code, and deploys the code to staging and then to production. That's the continuous delivery, basically adding the last line. Okay, so continuous integration is essentially committing the source code and then building it, but then taking it to the staging and to production. That's a part of continuous delivery. Okay, so the next part is microservices. You will hear this very often if you're going for software developer, SDE or SDM, any of the interviews, or even if you're going for DevOps engineer. These terms will help you in the interviews. So microservices are essentially small services. Okay, like I was describing that in case of Amazon detail page, we had hundreds of features. These hundreds of features were being delivered by hundreds of services. Okay, there's a very nice graphics coming up, and so microservices essentially are small programs or small software programs that listens to the user at HTTP port, and then responds to the user using certain plain text mechanism or any other mechanism. So microservices are single application focused, single use case focused applications. Each service would run as a separate process. Okay, so microservice communicates with other services. Each service, let's say you are accessing the Amazon.com website and you are accessing the detail page, is going to talk to multiple small services in the back end and assemble the outcome and present to you. The microservices are built around the business capabilities so that the people who are owning the delivery, they should, in case of Amazon, if let's say there's a team who is owning the delivery, they would expose a service for delivery related queries. While those who are running, let's say, Amazon payments, they will create their own service and expose their features. So microservices are built around this business capabilities, segregation of business capabilities. Each service catered to a single use case of a single business. Like for example, you have mobile app or a browser or any other front end. They both are hitting the different endpoints. The mobile app is going to the API gateway while browser is going to the web front gateway. Now, this is a classic example of Amazon whereby you have account service, inventory service, shipping or delivery, and so on. They are maintaining their own database. These front ends are not going to directly access their database anyone, right? Because this is something that they will have to own it. This team, shipping team, is owning this part, both of them, database as well as the software. So and inventory team is owning these two parts. Account team is owning these two parts, and they are behaving as if they are company in their own. And this is how most of the complex systems like Amazon.com is built. That's where we started this discussion today around how would you build Amazon.com. Now, earlier, before this magic of microservices started, this is how people build. Whether it's mobile or browser, both hit the same application server, different URLs, and there's a database. So if this goes down, everything goes down. Also, if there's a bug in this, both are impacted, and this database is the bottleneck. And also, if there are multiple managers for multiple features, they're all poking into a single server, and that's not a great thing. There'll be always conflict of interest. There will always be stepping on each other's foot, and that way the work will not work. I mean, the whole process of deployment will become slow, and hence the changes and errors will not be caught. Therefore, one of the things that worked out in case of continuous integration or delivery are the microservices. Now, in case of monolith as in monolith made out of single stone, that's called monolith, right? So in case of monolith, there are two gateways. One is API gate. Let's say there are two mobile app, two endpoints. One is mobile app and other is browser. If these not endpoint, these are the user facing interfaces. They both are, let's say there are lots of users. So the way people do is they basically deploy these app servers, and these app servers talk to their databases. Now this becomes very hard because all of them are talking to the same database, and hence only one will be active, remaining two will be the backup, and sometimes it becomes really hard to scale. Even with the NoSQL databases, there's going to be only one machine which will accept the write as in modifications, and hence this will not scale enough. Okay, so with the monolith, even the horizontal scaling is a big challenge, and that's why microservices have been wonderful. The next one is the infrastructure as code. I might need say 5 more minutes or 10 more minutes probably. Now, infrastructure as a code is basically creating the infra automatically by the way of code and deploying it. And that has been brought in by the way of these new tools and practices combined together, such as using a continuous integration, continuous workflow, along with the automation, along with the Docker and Kubernetes. So infrastructure as a code is that you define the infrastructure as part of a configuration file, put it in the Git repository or some other version control, and the program will pull that configuration, install, create the entire environment from the configuration or the code, and then deploy it. And this is isolated from the remaining environment, remaining machine, by the way of these new techniques like Docker, and will be deployed using Kubernetes. So infrastructure as code is something that is very much in use. This is not a hypothetical or a future vision part. It is real. This is how most of these systems are maintained. No matter how many engineers you have, if you don't have automation, all these engineers will be kind of stuck with each other. The overall process will not work out. So infrastructure as code is a combination of Chef, Puppet, Ansible, Terraform, and even the Docker and Kubernetes. We will see it in more details as we go ahead. All right. There's a question that Amazon only uses wrappers around monolith code based DBs. Not really, not really. Every team has their own databases. There are central databases that people use, but it is very hard to say who is using which database. Like I was in Amazon detail page. In Amazon detail page, some part was being served from Oracle database. Some part were being served from the NoSQL database. All right, and therefore there is no way to say. And moreover, since every team takes a call around which database to use, so it's not really so easy to pinpoint which database is being used. All right. With respect to the monitoring and logging, you monitor metrics and logs to, you always monitor the metrics and logs to see how application infrastructure is performing, and in case there are bottlenecks, you take necessary actions. The monitoring and logs, so what you do is you generally collect the metrics and logs from the application servers, bring it together, and then observe those together. Because if you have like 100 machines running the same code, some users are accessing one server and some are accessing another, bringing all the logs together is something very, very important, and then you analyze or visualize to fix it. This will be done using Grafana and other tools that we'll be discussing. Collaboration is a cultural norm, or you can say the cultural part of the DevOps is the collaboration. Collaboration in terms of code, collaboration in terms of specifications, collaboration in terms of the process, collaboration in terms of guidelines, collaboration in terms of product features. Everything needs to be everything needs to be clear to the team, and hence the collaboration amongst the team is the important part. Earlier, what people used to do is they will basically break the parts so much that no two persons know what's going on. And these days, that's not the case. That's not the case. And even though at Amazon and elsewhere I worked, even though every team owned certain piece of work, but they communicated what each other needed to know about each other. Every service was documented well, specifying who is doing what, specifying which service is providing what, specifying what kind of throughput each service can handle, and so on. So the collaboration is an integral part of everything. So we must have clear practices for collaboration. Now, so with respect to this course, the hands-on, how the hands-on will be done, 90 days lab access will be provided to all those who are enrolling into the course, and few fundamental tools such as Git, such as the Linux, such as let's say the build tools. All of these can be practiced on the lab, but we will strongly suggest that instead of we imposing that you should use cloud lab for everything, you should focus on what is the right thing to do. In real life scenarios, most likely you are going to use AWS or GCP. AWS means Amazon Web Services or Google Cloud Platform. So create your account there, because we are going to focus on how to deploy your code and your work to AWS and GCP. Therefore, it is important for you to create accounts there. We want our primary focus is that whatever you learn in this session, in this course, should be really applicable to your projects, your career, and therefore we want to do a very practical hands-on with AWS and GCP, and wherever needed on CloudX Lab. So all right, now there are few frequently asked questions I'm going to go over. First question is, I am a software engineer or SDE or SWE. Will this course be useful to me? Yes, this course is going to be extremely useful to you, because it will help you learn the best practices and tools for building better software for a larger number of users. It would help you learn how to deploy the software. Second question is, I am a system administrator. Will DevOps course help me? Yes, of course. It would help you learn the best practices and tools for building software for a large number of users. It would also help you learn how to deploy the software. If you are a system administrator, there are two kinds of things you generally do. One, take care of the production machines. Take care of if you're a system administrator, you will take care of the production databases, production servers, as well as you'll take care of the testing servers and so on, right? And therefore DevOps as a culture will be established by you. DevOps as a culture will be established by system admins as well as engineers together. Otherwise it won't happen. Next question is, I'm a machine learning engineer. Should I attend this course? Of course, you should attend the course. Let me give you an example. Machine learning engineers or ML engineers need to deploy the models as service. This course will help you understand how to deploy models as services. We will have a project involving deploying the ML models as service. You will learn how to manage your training project code using Scm and other mechanisms. I'm a front-end engineer. Is this course relevant to me? Yes. Front-end engineers do a lot of coding. The code needs to be managed using the source code management tools. Second, while testing the front end, you usually need to deploy, and therefore it is needed to be involved in the continuous deployment. For testing front end too, you should build a practice as mentioned earlier. You'll be amazed to know that this is something that most of us avoid. That hey, I'm a front-end engineer. I don't need to learn all that back-end thing and DevOps. No. In case of in one of the companies, I'd already told about the name. So in one of the companies where there were larger user base, we wanted to test our website as well as web app in all the phones, right? And starting with the front end, we wanted to test in all kinds of environment, like horizontal phone, vertical phone, and so on. So we needed to set up a process whereby it will automatically package an app and push it to all the phones and take the screenshot of the page from all the phones, and then we'll also rotate the phone by using a physical motor, and then we'll take the screenshot of the rotated page. Now that helped us understand how responsive is our website as well as web app. So this was not really possible unless the front-end engineers were not involved in the DevOps, because most of the automations, they were the key people in most of the automation. DevOps, so this is the final slide. So there are only few seats left, since it's a first course on the DevOps from us, and since it's our core specialization, as in we strongly believe that everybody in the engineering team at CloudX Lab should have a good hands-on experience with DevOps. As a culture, we want to we promote it in the company, as well as the team members, Abhinav as well as Ashok, both come from great backgrounds. Therefore, this course is in high demand, and hence there are only few seats left. And the second session of this course will happen on 28th March. It's 7:30 a.m. to 9:30 a.m. PST. And the course fee, you can take a look at the website. And the DAV 10 is the coupon. All right. There is a question that's a very interesting question. I need to answer this. Question is, I'm a senior manager with technical interest in latest technology. Is this going to help me? Yes, yes, and yes. Very good question. So the DevOps as a culture is owned by engineering managers or software development managers or CTOs, and the teams like the sysadmin team, the front-end team, the back-end team, the engineering team, the software development team and the machine learning team all need to be brought together to bring the DevOps processes, and that's a key role that a software senior manager plays. An engineering manager plays that kind of a role, and it is extremely important to know what the tools looks like, even though you may never use Git, even though you may never use the Docker, right? It's extremely important to get hands-on. Otherwise, even if you are a non-tech person, it'll be very hard to make the decisions unless you know how it feels to use Docker, how much time it takes to deploy an image. So unless you know those parts, it'll be hard for you to make decisions. So my suggestion is generally this: in organizations, whether you do it or not, but you should know it. You should toy around things. You should toy around things. You should know exactly how it feels to use things, right? And you use these DevOps tools and how it works well together, right? Only then you'll be able to lead. You'll be able to work in an environment, or you can collaborate in an environment where these DevOps tools are being used. Otherwise, all of this will remain as a theory. So it's extremely important for engineering managers also to learn about it. All the great senior managers that I have met are the people who are very hands-on. Only then they are able to direct their teams. So thank you so much for a wonderful set of questions. You can go ahead and enroll into the course. This is probably few more seats are left, and a question is, will this course be useful for assistant professor? Yes, yes. So actually we were planning to launch this course with one of the very prominent college, and then we realized that none of the professors had this experience, and the reason is that this discipline has come strictly from the industry, and therefore it'll take a while for this to be accepted by the institutions. The professors should know this part because they have to train their students. They will have to also make the students usable in the industry. So it will definitely help you, and it will also help you do the real software development in your consulting project. Let's say you are picking a consulting project. In those projects, the DevOps practices will help you. Great, wonderful questions, and I hope that this was useful to you. This is probably the most theoretical session we had. Remaining sessions are going to be more hands-on, less theory. All right. So there's a question from Rahul that I'm a project coordinator in operations. I want to switch to DevOps. Is DevOps could be a career for me? Yes. So in DevOps, there are many phases, and trust me that even if you are not very great with coding or you are not very great with algorithms, even then you can handle the DevOps, right? And it is integral part of the software engineering, and hence almost every company who is serious about software development, they are going to implement and use these practices. And in an organization, there are more and more demand of DevOps engineers. So it's going to be quite useful to even project coordinators, because if a project coordinator knows what tools takes how much time, which engineer can work on what, it'll be easy for the project coordinator to schedule and so on. Especially those project coordinators, those who are interested in working in agile teams, who believe in Scrum, who like continuous deployment models, they're going to really like the DevOps teams. The teams or companies that have DevOps practices pretty well, and they will be one of those key drivers to drive the DevOps practices. Great. So this was the first session. I look forward to see you all in the second session. Have a great day.